Hi, and yeah, thanks for taking the time to have a look at Reskube. This is a very, very quick demo, just explaining how Reskube works, and so you can see it in action. You can find out much more, of course, online, and do get in touch if you want to look in more detail. Great, so we've got two PCs. The one on the right here represents a standard home PC that's unsupported. We've got YouTube News, and we've got Chris on the other end. Hi, Chris. And on a Zoom call, and we've got a recursive ping here, which is showing us pinging out, making sure the internet is there. On the left-hand side, we've got exactly the same setup, but this one is supported by a Reskube, and I'll show you the Reskube. It's just down there. And that's providing uninterruptible power and uninterruptible internet. So what we're going to do really is compare how the two PCs react. Both are connected to the same internet source, which is a router just to the left of the screen, and both are connected to the same power source. So what I'm going to do first is cut off the internet, basically by turning off a router. Hopefully you'll be able to hear a click. Now what you'll immediately notice is that the Chris on the right here is frozen, Chris on the left hasn't frozen. This YouTube is buffering, or has buffered, but what you'll notice is the ping has timed out, so there is actually no internet to this PC now. So in a few seconds this YouTube will freeze, and actually this Zoom call will drop off. And what you'll see on the left-hand side, of course, is that there is no problem at all. Chris is still working away, and we're still having the Zoom call. We're still receiving the news, and unfortunately, usually bad news. But underneath here, we've got the recursive ping, and that's just showing us that actually it's still connected to the internet. There is no problem. Now, of course, in many circumstances, as in fact there was yesterday in London, and as a result of many of the storms, power goes out as well. So occasionally there are these power cuts, and if you're doing something critical, of course you don't want to stop work. I'm going to simulate a power cut simply by turning off the power. So there we go. And what you'll hear is the beep, which is basically Reskube saying we're actually on battery power now, and that battery power will support a configuration like this for about half a day, and support a laptop, and provide all the internet access for about 10 hours. So again, you can see that this home worker is stopped dead in their tracks, whereas this home worker is just continuing. Great, so that was it. Very, very straightforward. Always on power and internet in a box. So what's the difference then between Reskube and, say, a UPS and a 4G failover router and a load of cables that you might send out to some staff members? Well, the real difference is the fact that it's enterprise grade. And what I mean by that is that if you're sending out a UPS and 4G failover router, a load of cables out to your staff members, there's a number of issues with that. Many of your critical staff members will be critical, but not necessarily technical, and so it'd be actually a complex matter to get them to set everything up correctly. And even then, you're never quite sure whether it's set up correctly, because you can't see them. So you've sent these devices out the door, and pretty much that's it. You've never seen them again. So with Reskube, we have a remote management dashboard, which enables you to interrogate the remote devices to make sure they're online and correctly configured. It means then that you're able to report on them, so you can actually prove that you have that level of resilience for those staff members. And very importantly, it means that these high-value staff members, when they need support, are going to actually have better support, because you'll have better visibility into the infrastructure that they have at their end. So you're able to faster diagnose and faster remediate any problems. So Chris is going to run through the remote management dashboard and explain basically how it all works and how the IT teams can see and help their remote users.
Thanks, Andrew. So a quick look at how the RMS communication works. The Reskubes are connected to the RMS via the internet using message queuing, telemetry transport and TLS. The admin connects into the RMS via two-factor authentication over HTTPS. Our platform is hosted on AWS, and we take advantage of their highly resilient and secure infrastructure. All features you'll see in this demo can be fed into your own portal using our secure API. Okay, so I'm just going to be logging into our RMS and demonstrate two-factor authentication. And it should be authenticating now, and that's us logging in. So this is our RMS. From this front page we can list all our Reskubes allocated to this account. We can import these in bulk via CSV. We can also import tags in bulk via CSV as well. And we can allocate these tags in bulk as well to certain Reskube devices. It makes it easier to track and select Reskube devices by clicking on the tags. We can also see straight away which Reskubes are online and offline, when they were last updated in RMS. Also the mobile signal quality as well. How the Reskubes are connected to the internet. These could be via a WAN Ethernet cable, via a WAN Wi-Fi interface connection. This depends on how the Wi-Fi coverage is from where that Reskube is. It could be up in the office and the broadband router downstairs, or via the mobile network as well. And then the mobile network will then fail back over to the Wi-Fi or the other primary interfaces when they're back up again. We can also see what carriers they're currently connected to as well. I'm now going to click on the Reskube currently online and we'll see more detail. Each Reskube has 2 SIM slots and they work in an active passive failover configuration. Auto switch cases between the two could be weak signal, drops below a certain threshold, data limit, no network, network denied, or data connection failure. We can also see the monthly data usage of each of the SIMs here as well. More information on its current WAN interface in use. Also, device history. By default, the Reskube will update the device history information every 30 minutes, and this can be disabled at any time or extended or decreased. An example of the update history is listed here. And by a given date, we can see on a selected parameter information on its WAN IP and listed here. The recent network events, these can be set up as alerts. These alerts can be sent to a specific email address. These alerts could be signal strength, if it drops below a certain threshold. Also SIM switch, when the SIM fail over between each other. Status change if it becomes online or offline. Also mobile data thresholds as well. And reporting is also another useful feature. From here we can set up periodic reports over a daily, weekly or monthly period, or we can set up a single report over a given time. This could be the last day, the last week, the last month, or even a custom date range. These are some of the demo reports I've created. I'm going to generate one now. This is a demo report over the last month. That should be generating. And I'm going to view the report now. So from here we can see that we can report on router uptime, mobile connection uptime, mobile operator carriers in use, data usage, and signal strength as well. We can also download this report as a PDF. Once we do that, we can see a bit more detailed information on all of the Reskubes on that report. We can also securely connect to devices attached to that Reskube unit via RMS Connect using the protocols listed here. I'm going to demonstrate that using remote desktop, which has been enabled on that end client machine. Just going to click on that now, and we can see that access is logged here, so we can trace back on who's logged on when. I'm going to just generate the proxy link now, which we can delete at any point, and enter the local credentials of that end client machine. And now we're going to try and connect in via RMS Connect using RDP. That's me logging in. As you can see, I'm now logged onto the end client machine using RMS Connect and RDP. There we go. And then at any point we can just log out and disconnect from the session. And then we can delete the proxy link just here.
Thanks, Chris. And that was the RMS. You can clearly see how useful that is in firstly ensuring that remote individuals and teams are resilient, but also, of course, in better supporting them by having greater visibility into the infrastructure at the remote site. So if you'd like to see more detail, please do get in touch, and yeah, we'll look forward to speaking to you.